So let us see what we studied in the previous class. In the previous class, we done the flip-flop. We wrote the program for D flip-flop as well as we written the program for JK flip-flop, then T flip-flop. Next, we started shift register also. Then we wrote the program for counter. That is normally the binary counter. It's a binary up counter. Then binary down counter. Then we said some work actually how you can write the up down counter and the BCD counter. So now let us write the up down counter and the BCD counter out here. I hope I given the workers for you. Let me write even though right here Verilog code for up or down counter. The counter has to count like this. The output should be like this. Output should be like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 7, 6, 5, 4, 5, 6, 7, 8. It has to go like this. You can see here, this is nothing but your up counter. It's counting up. It's counting up. Then here again, what happening? This is counting down. Actually, this is counting down. This is counting down. Then again, this is counting up. So this is what we are going to write the program, how it has to be counted. But just randomly written, actually the counter will count up, then down, again it's up. From this number itself, it has to do like this. So now for this, how we can write the program. Let us see. So further, what I will do, first let me draw the diagram, the counter diagram, what and all is required. Okay, let me draw. This is the counter. The input is, as you know, it required what? Clock. This is the clock actually. Which clock? You can say this is a positive edge clock, you can say. Next, we must have one signal, that is nothing but a reset signal, because you must reset the counter. Before the counter starts, you must clear the counter. Then only the counter will start to count. Else, if you are not clearing the counter will not start. In the sense, you have to clear. Next, what I'm going to get the output as here. Output is Q. We have to get. Now I need to get two things like up and down. So what I will do here, I will give one thing. The additional signal is nothing but a control signal. This is a control. So what the control will do in the sense, say example, here the control will do like this. When control is equal to 0, then it will count up count, and control is equal to 1, then it will down count. This is what we are going to do now, because else with the single we cannot perform a count operation. So I need to have one thing with a control. So now let us write the program here. Q is output. Now let us start. Module. It is a counter only. It's an up down counter. Up down. The inputs are clock, reset, then control, then Q. These are the Input and output variable. The inputs are the clock, reset, and the control are scalar values. Then output is Q. It's a how many bit counter? It is a 4-bit counter. So the 4-bit counter in the sense you have to write 3:0. That is nothing but Q. Next, reg 3:0 Q. Next is always at was age clock. Begin. Now first what you have to do? First you must clear the counter. So if reset, then Q is equal to 4-B0000. So first I clear the counter. Next what I should do? Else if I should go like this. Else if means what is the meaning of that? Reset equal to 0 means the counter will start to count. Now you need to say whether it has to perform up count or down counter. So else if CTRL that is not, you can see that because control 0. So you have to give like this. This indicates control is equal to 0. This exclamatory mark is nothing but its logic control is 0. If the exclamatory mark is not there, it is control is equal to 1. So even we can write like this also. Else if not control, that is the meaning of the control is 0, then what I'll get? Q is equal to Q plus 1. It is down count, up count. So Q plus 1. Else means what? If the control is 1, then Q is equal to Q minus 1. See, now it's performing both the counts. So end module. Now we can see here after begin, if, reset, there's one concept here. See, and say here this portion is for up count, this portion is for down count. This is for up down count. This is for up count. So I can say here, this is up count, this is down count. You can see now how it will work now. You can see module up down counter. What will happen? First, what you have to do, you need to give reset is equal to 1. This is the meaning of this, right? So I will write here. So for your reference, means this is reset is equal to 1. That is the meaning of that. Reset is equal to 1. Then here also I need to give. So let me write here. That is command. I'll give the command. Not CTRL is equal to, that is meaning is what? Control is equal to 0. Not means CTRL is equal to 0. This is the meaning of that. So reset is equal to 1, you need to clear the counter. When reset is equal to 0, it will come for this condition, it will check for control. If the control is 0, it will perform up counter. If the control is 1, it will perform the down count as per this condition. So when you do the simulation, so we will get the output as like this. It's a 4-bit counter. I hope you might have understood this. Okay. Now what we will do? Next, let us write here Verilog code for BCD counter. So BCD counter in the sense, what is the output? The output is how it will count? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. BCD values 0 to after 9, again 0 will go 1. So it has to go like this. But it is a 4-bit counter. From this only I can understand it's a 4-bit counter only. So let us write now. The program we have to write now. Module BCD counter. So BCD underscore counter module name. So what is the input? Same even here also the input is clock reset, then Q. Clock reset and Q. Next input is clock reset. Then output is Q. It is a 4-bit counter. So 3:0 Q. Next register 3:0 Q. Next is always at passage clock. Passage clock. Now again. Now you tell me, you can write. First we should make reset. So if reset is equal to 1 means reset is equal to 1, then Q will be 4-B000. You need to clear the counter first. Next else you have to go. Now you think the BCD counter. So the counter will start to count. If I write like this, see, I don't write. Now I'll put a condition like this. Q is equal to Q plus 1. If I write like this, will it correct?
No, sir.
It won't be correct. The reason is
BCD will count
up to
it will count from 0000 to 1111, sir.
As per this program, it will count up to 15, 111, correct? As per this. But we need to write the program for BCD. So it has to count up to 9. You see, this condition will count up to 15. But it has to count up to 9 only. So what I should do? I should modify this program. That is nothing but else if Q is equal to 4-B1001. This is the equivalent of 9, right? Once the Q reaches 9, then what will happen? Q should become as what?
Reset.
Yes, it should be reset. So B0000. You correct now? Else if Q is equal to 1001, then Q is this. Again, what is it? Else. What is the meaning of that? If the Q is not 1001, then what will happen? Q is equal to Q plus 1. I hope you understood this now. Now it will count up to 9 only.
Yes, sir.
Yes, now it will count, right? So now once the count Q is equal to 9 is reaches, automatically then you get a 0. Then again, what will happen? It check the condition, the 0 plus 1, 2. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again 0, 1, 2. Like this only it will start. So this is the program for BCD counter. It is you can write in any way. It is not mandatory you have to like this only. You can apply your own logic. As the programming subject, you can apply your skills, the programming skills, and you can write a program. This is just I'm giving some simple solution for you how we can write. This is the BCD counter. Now you can think what is a decade counter? What's a decade counter?
0 to 9.
The decade counter will count up to 10. Right. Same program only you have to do. What you have to do? Q is equal to 1010. It will be 0. That is the modification we have to do. Yes. Okay. Now we need to write the program for random sequence counter. Write here Verilog code for random sequence counter. The random sequence counter in the sense the given sequence is I'm going to give you the sequences, nothing but 0, 2, 4, 6, 1, 3, 5, 7. See, after that 0, 2, 4, it will continue like this. What's happening? The counter is counting first the even numbers, then it's counting the odd numbers. But you can see again, just I am explaining here, module random clock reset Q, the input clock and reset, the output is Q. Now here first the output is Q as is given. Next, the register we created, the temporary register is created as temp variable because whatever we are going to do, the temp will be acting as present state and the next state. The temp will be acting as present state and the next state. Where sometimes the temp may act as present state. So what is the next state will be this. Like this only will write. So now always at the passage clock begin, if reset is 1 in the sense, the temporary will be is equal to 0. Still, you may think in this something is missed out here. What is missed out actually? We have to get the output in Q variable, but the Q variable is not shown here. That is the thing you may thinking. So how to write that in the sense? So that has to be written here. Assign Q is equal to temp. Now the temp is assigned to, see now the temp, whatever the value I am getting in temp, it is assigned to Q. That is what we done here. The sense. So now is case temp. First reset is equal to 1, temp is equal to 0. When reset equal to 0, it will enter into the case statement. Now we'll check what is the temp value. At present, this temp value is 0. So when temp value is equal to 0, this is a temp is a control variable. It is 0. The next what will have temp will be 2. Next again it will go to case statement. What is the temp? Temp is 2. Then it check temp 2 means it be 4. That is present state is 2. Next state is 4. Next again you go 4 means 6. Next 6 means 1. 1 means 3. It will do like this in loop wise will get. So it will count as like this 0, 2, 4, 6, 1, 3, 5, 7, again 0. Finally, each and every time the temp value will be assigned to Q. When means for every positive edge of the clock, the value will be assigned to Q. This is what will get happen.